Good morning, afternoon, or evening, depending on where you are today, and welcome to today's webinar, IoT Security, New Approaches to Authenticating Devices, jointly sponsored by DigiCert and Device Authority. My name is Jeff Chandler, and I'll be your moderator. And we know we have a large number of attendees from all over the world, and we really appreciate you joining us today. We know that IoT device authentication is a topic that many are dealing with, and that you've joined us looking for a solution. We have a great speaking panel, and we're really looking forward to letting you hear from them. But before we do that, I'd like to just review how you can actively participate with us. We anticipate that many of you will have questions, so if at any time during the presentation you have a question for our speakers, please type your question into the Questions tab on your GoToWebinar control panel. You'll see that on the right-hand side of your screen. We will be monitoring that Questions tab actively throughout today's presentation. And please keep in mind that there is no need for you to wait until the end of the presentation to submit a question. Go ahead and type it in at any time. Also, because we know that we have many attendees today, we may not be able to get to all of your questions, but we will absolutely do our best to answer as many of them as possible. At the end of today's presentation, we will be providing contact information for the speakers so that if you so desire, you may continue the conversation with them offline. Now on to our main event. We have two amazing speakers with us today who collectively bring many, many years of experience with implementing PKI in real-world environments and who are involved on a regular basis consulting companies on how to secure their IoT device deployments. First, allow me to introduce DigiCert Chief Technology Officer Dan Timpson. Dan is responsible for DigiCert's technology strategy and plays a key role in leading the security industry by driving new initiatives. At DigiCert, Dan's team innovates to simplify certificate management for DigiCert customers and to strengthen the security of DigiCert's products against evolving threats. Dan's experience spans many years, and in his current responsibilities, he frequently speaks at conferences and consults customers on best practices for IoT device identity, to include device authentication, data encryption, and data integrity. Dan, thank you for joining us today.
And thanks, Jeff, and in advance, thank you to the audience who's participating with us today.
Very good. Joining Dan today is Device Authority co-founder and Chief Technology Officer, Talbot Harty. Talbot has deep experience in security and product management that spans many years. Prior to founding Device Authority, Talbot was the Chief Development Officer at Network Equipment Technologies, which was later acquired by Sonos, and where he was responsible for redefining the company's vision and product strategy for unified communications, SIP trunking, and enterprise mobility markets. Talbot was also responsible for the company's tactical deployable secure communication solutions, which are widely installed today throughout federal DoD agencies, the UK MOD, and NATO. Talbot, we're really looking forward to hearing from you today.
Thanks, Jeff. Glad to be here.
So finally, before I turn the time over to our speakers, let's quickly review our agenda. We have some great content ahead, and we'll be covering some important information, including talking about PKI and the role it can play in IoT security. We also want to talk about the need for owner-controlled security postures with our devices in the IoT, and we'll define a little bit more about what that means in just a little bit. Also, we're going to talk about the challenges in managing PKI at IoT scale, and then finally, we'll leave you with some solutions that you can look to implement in your organization, particularly as we address the need for security automation within the IoT. So with that agenda in mind and with the content we have, I don't want to waste any more time, so I'll go ahead and turn the time over to you now, Dan.
Great. Thank you, Jeff. When we talk about building trust, we want a proven framework that promotes security. The components of authentication, encryption, and integrity checking provide this framework for trust. When we consider device authentication, for instance, the goal is really to allow the right or authentic devices to authenticate to our systems, such as maybe an insulin pump, for instance. Who are we communicating with? What are we communicating with? This authentication combined with access control can give us kind of a quote-unquote identity fabric that can handle transactions going between a person to a device to a device, a server to a device. It's adaptable and flexible. We all like privacy, and so encryption is important. We need data in transit, data at rest. Factors that might include, does it need to be encrypted? What are the data processes in memory, for instance? And then lastly, when we talk about integrity in system data, firmware manufacturing considerations, is secure boot, is it built in? Is there device signing? Is there binary signing? All manufacturers are interested in keeping their IP protection safe and sound, intellectual property interests, and to avoid black market devices, that midnight production run. So we want to ensure that they have authentic devices. Like the authentication, when we talk integrity, there can also be message signing, so there's no compromise when we talk device to device, device to server, human to mouse. So this trifecta of authentication, encryption, and integrity checks, it really gives us compensating controls, it's cryptographically secure, and it gives us the trust that we're looking for, especially as we evaluate IoT scenarios going forward.
Thanks, Dan. Those are all good points. Definitely these three things I see as absolutely essential to establishing a security foundation for IoT. Obviously, you've got the identity being authenticated. You've got the need for data protection through encryption. And then you've got that integrity validation that's absolutely essential so that you can trust and trust how you're getting that information, what is generating that information. And PKI clearly plays a huge role in establishing that trust foundation. But the key, I think, comes down to controlling, who is controlling that PKI that's in play for providing these functions. And one of the things that I want to talk about here is the need for owner-controlled security posture. The stakes for IoT are escalated. We're now introducing connected devices that can introduce physical consequences into our lives. That can be extremely dangerous or life-threatening in many cases. So getting this security right for IoT is absolutely essential. If we take a step back and we look at how PKI has been involved with connected device previously, we can see that we can learn some things from this report. So there was an SEC Consults report that was issued several months ago. It was their House of Keys report, and the report highlighted a major problem with device manufacturer PKI security. At the time of the report, there were 3.2 million internet-connected devices using only 580 unique private keys for securing their traffic and access. The problem was directly attributed to the design and manufacturing processes used to create those embedded devices. A recent follow-on report shows that this problem has only gotten worse with the growth of internet-connected devices. So the main takeaway here is that manufacturer-based PKI security is not viable for IoT devices and applications that pose a physical threat when security fails.
Yeah, all good points, Talbot. And just to add to what you mentioned there, I think part of the problem is that when we consider how PKI is integrated or adopted into development processes or manufacturing processes, there's still sort of a waking up that's going on as to how this can be done the right way, which I think speaks to part of the problem with key reuse and not really understanding or following the best practices.
Yeah, exactly. And so, what else? There's another study that we can learn something from, which is this HP study that reported that the vast majority of IoT devices do not employ data encryption. In other words, they're not designed to secure the data that they're generating and sending, and as a result, both the source of the content and the data from these devices is suspect. This study highlights that device manufacturer PKI would actually be a security improvement for most of the IoT devices that are deployed today. However, the shared private key problem that I pointed out on the previous slide compromises any potential security benefits that we would get from that. And so that's why the best security posture is going to be owner-controlled security posture. This is particularly true for industrial, healthcare, transportation, and SCADA-related applications. Owner-controlled PKI provides independent security for device authentication, data security, and device updates. So let's take a look at some of the key concepts surrounding owner-controlled device authentication. So the first thing we need to look at that is essential is the onboarding process. And in that onboarding process, an IoT device it controls how the device is secured during the registration process. And we need a secure onboarding process. The process identifies and controls the devices that are known to the IoT application, and it establishes the conditions for provisioning PKI security credentials. Next, by combining the device authentication with policy-driven authorization, we can control the specific conditions under which the device will be trusted to communicate with the application. This policy-driven authorization reduces the threat surface of the IoT application by removing what would otherwise be common or macro-level or universal threat exposures and vulnerabilities associated with the device to the application. And lastly, we want to reduce the time window vulnerability associated with the security credentials themselves and the authentication process that occurs when the device comes in to connect with the application. In essence, we need security that does not simply rely on static credentials and turns IoT devices into the moving targets that discourage and frustrate potential hackers. These principles work together to establish trust anchors for IoT devices and applications. Dan, did you have anything you wanted to add to that?
I agree with everything you said there, and when it comes to the trust anchors, what we're seeing is there's an evolution with, let's say, public trust stores that we've been leveraging in the past, and now that is becoming a question or problem to solve front and center for organizations who are rolling out a PKI for IoT or otherwise.
Great. Well, now let's, Dan, why don't we turn it over to you and have you talk about the challenges in managing PKI at IoT scale.
Sounds good. Thanks, Talbot. So really, just as we were discussing, public trust a few years ago, when we analyzed certificates worldwide, for instance, there was maybe 4 to 5 million publicly trusted certs between all of the certificate authorities. And now we're seeing the trend where an individual customer may need 4 to 5 million certificates for their user base or for protecting IoT applications and devices. So really, the job now is to enable these organizations to create private PKIs, still leverage public PKI infrastructure as well. And in order to do that, we need custom profiles that will be working on these IoT devices. We need deployment models that are not manual, but rather that are automated throughout the whole life cycle. Scalability is obviously a big concern when we talk about managing millions of devices instead of just a few thousand, for instance. And when we talk about managing at scale, the life cycle is really management by exception, where the problem cases surface up in an intuitive way, allowing administrators and those in charge of the system to take care of the devices through the life cycle. And then, of course, there's trends and emerging protocols, IoT protocols, which all are very ripe to ensure that we've got proper security throughout those protocols. And then devices today are not powered the same way. You know, Gartner's done a nice job of laying out the different classes of devices, but when we have sensor nodes, for instance, there's low power consumption considerations and low compute considerations that we need to consider.
So Dan, at this point, let me just interject with a few questions. We're getting a number of questions from our attendees, and we appreciate you submitting those questions via the questions panel or the tab there on your GoToWebinar control panel, so keep them coming. We received a question here about if we have IoT devices in the field for years or more, how can we put security certificates on those devices that don't expire?
Yeah, so that's a great question, and certainly with private PKI you have the flexibility to add validity dates that don't expire or go very far into the future. And so my recommendation would be to look at your threat model and understand how the certificate's being used for identity for that device. Are there other aspects of the device and identity that are also being leveraged? And if your use cases around managing the identity need a long-lived identity, that could be a good way to go. In general, though, we're in favor of refreshing the keys and building in controls and mechanisms into the devices and the surrounding systems that would refresh that identity over time. And I don't know if you have anything to add, Talbot.
Yeah, what I would say with that is really if we're just using time expiry alone, we kind of introduce this basically single dimension of expiration. And there's a lot of different conditions that could occur that would basically trigger your desire to rotate those credentials. And they may be something to do with the behavior of the device, the location of the device, the software or firmware version that is deployed to the device, etc., that might put it in a state that would trigger an unauthorized condition. So the ability to combine for those devices that have the compute power to do that, the ability to combine that policy-driven authorization with the validity of the security credential itself is extremely important. And that coupling today doesn't exist. It's kind of a binary solution unless you have a, if you have a credential management solution like you're going to see here in the demo, then obviously you can do that. For the devices that the questioner may be referring to, there's a lot of legacy kind of brownfield sensors out there that may or may not be able to support this kind of owner-controlled security posture. And I think what they're doing in those environments is the identity assertion and the credential management and so forth is really the role of the IoT gateway, and the stuff that we're talking about here would then apply to the gateway that is asserting the identity on behalf of the sensor.
Okay, very good. Thank you both. A couple more questions just so we can keep up with our listeners. One question we had was, what are the device level and system requirements for implementing PKI on connected devices?
Yeah, another good question. So that's very varied, and so Gartner talks about their class 1, 2, and 3 devices, and so it really depends on the capabilities. If you've got a fairly sophisticated device with operating systems that can do key management, it's pretty easy to do. With the sensor node level, like what Talbot was just talking about a minute ago, we have to look to the capabilities of the gateway or the surrounding technology to push PKI a little bit lower down in the stack. And we'll get to some of this in the demo.
Okay, great. We also received a question about protocols, kind of how new IoT communication protocols interact with PKI. Talbot, is that something you want to address?
Certainly. So obviously there's new protocols coming out. Most of the IoT protocols that are coming out are really trying to provide optimized communication to enable low power, low compute devices, and in particular also low bandwidth connectivity to do a couple of things. Obviously, one, the lower compute power on the device, the longer it will survive in a battery operated environment, and then the other things, the connectivity problem really just deals with bandwidth. And so all these protocols that come out today, and they're evolving. There's several of them out there. There's CoAP, there's LoRa. There's some in particular that deal like SCEP that are dealing with the provisioning of PKI. They've been around for a while. You know, my view on those is that they have to be implemented and well designed and supported in the provisioning process and the registration process, which needs to be a whitelisting process. So we basically have to go from the idea that that the manufacturer owns the device, and in these cases where we're deploying, I have to take possession of that as an owner of the device, and I need to be able to identify and authenticate and have a protocol of supporting that ownership transfer and that introduction of that device as a trusted device into my application. So I think a lot of those protocols are useful in helping facilitate that efficiently. Each one of them have their own advantages and disadvantages, and I believe we'll see an evolution there as those protocols get optimized and we kind of deal with IoT security requirements.
Yeah, I would agree with everything you said. And one of the things that's interesting is if you're talking about secure device registration, that implies that you already have a secure channel set up whereby you are registering that device. And it's sort of the chicken and an egg problem. So when we talk protocols like SCEP, for instance, the surrounding technology around that, if you can enable it so that you've got that secure channel, great. But this is one of the points that we'll highlight in the demo in just a few minutes on how this happens.
Very good. One procedural question. One attendee asked if we would provide the slides afterward. As I mentioned before, we will have an on-demand recording available, which we'll send out in an email link. So you'll have the opportunity to have that in a little bit. Now, one other question, and then we will move on. Keep sending your questions, and we'll try to get to them as we can. We see more coming in, but let me get to one more before we go on to the next part of our presentation. The question here is, with PKI and IoT, how do you solve lifecycle management issues? How do you address that?
So, okay, yeah, that's a good, I'm wondering if we just go to the next slide since that is covered in the next slide. Yeah, thanks. So when we talk about IoT scalability, what's really required is kind of an integration with security, or with an integration with orchestration rather. So Talbot was mentioning a minute ago about the certificate generation process. We need to make sure that those devices that are requesting key material are authenticated properly. That can happen automatically. We talked a little bit before about the automation requirements, but what's important here is, can a device automatically renew itself? Can a device revoke itself when it's reached the end of life? And so those key operations suppose that the keys are adequately protected and the whole system is built so that this process can happen. So the takeaway on this slide is really that we need to embed in the life cycle and then the deployment processes that make sense from an IoT standpoint. So we'll transition it back to Talbot for a minute to talk about a little bit more on the automation problem.
Great, thanks, Dan. So I've put together this this illustration here. This diagram shows how Device Authority and DigiCert work together to deliver PKI security automation at IoT scale, supporting thousands or millions of devices in a deployment. The Cert Central Managed CA service provides trustworthy PKI credentials for the IoT devices, and Device Authority's Keyscaler platform interoperates with Cert Central to provide the policy-driven security and the orchestration for controlling the device registration and the PKI credential provisioning. First, the device is registered into the Keyscaler system, which generates PKI credentials that will be assigned and provisioned to the device. And next, the certificate is signed by Cert Central through the service API and then securely delivered to the device according to the Keyscaler provisioning policy. Let's take a look at this process in action through a pre-recorded product demonstration. So what you're going to see in this demonstration is that first we're going to take a look at the Device Authority control panel and review the Keyscaler system setup that supports the PKI security automation. This is a one-time step setup that includes the common name template, the provisioning policy, the device groups, and then we're going to get into the registration control record that we're going to use for onboarding the device automatically, and then we're going to get to see that whole automated device registration, group assignment, and the CA signed certificate provisioning end-to-end from the DigiCert service all the way down to an Advantech IoT gateway. So let's take a look at that. I'll comment as we go, and again, this is a pre-recorded demo of the system. So we'll start off in the control panel and just kind of review the setup. It'll include the connector profile. We've blanked out the API key and organization ID that we use to do this here, but that would be the owner's individual credentials. You can see here the common name template. In this case, we're going to use MAC address for the name source. That can be tailored, automated, through this system. And then we've got the provisioning policy here. So we're going to show where the profile and the CN template come in. We're going to specify the elements of the certificate, where we want it to land, how we want it to be stored, and what device group the policy applies to. And we're going to take a look at that group. We're going to see that there's a policy associated with it, and we're going to also see that there are no devices currently in the group. So next we're going to provision automated registration for devices. That can be done in bulk, or in this case we're just going to do one here. We're going to specify a platform. We can specify a MAC address for the device coming in. We can specify an IP address or subnet that's valid, or time windows, or geofences. And we're going to create that group association when that device comes in. So this sets up a pending record in the system. And when the device phones home and registers into this system, it will consume that registration record. So we'll jump over to the device, and we're just going to kick off a process to do that and tail the process so we can see what it's doing. So it's going to go through the registration process, and then we're going to bounce over and see that it got registered into the system. The registration record got consumed, and that gateway is now a member of that group. And then we can bounce back over and see that the certificate was processed, delivered from DigiCert, signed, and delivered down to the device with the entire signature chain all the way back to DigiCert. So that's a quick demo. It shows how we can support certificate management at scale for for this IoT deployments.
So we're getting a few more questions, Talbot, on this, and I wanted to just bring these up for you and Dan. One of the questions that we had received is asking about how you protect the delivery process from device spoofing or cloning, talking about delivering the certificate onto the device.
That's a good question. So as Dan mentioned, you've got this chicken-egg problem between, how do you get started with the security process? Device Authority actually has a very large number of device authentication related patents. I think we're up to almost 20 now, US and foreign, and we use that technology as a bootstrap for the registration and authentication process, and it allows us to tie definitively the device identity to the certificate, so we can in essence bind that identity and assign certificates to specific devices and have that authentication mechanism support the secure delivery to the devices themselves. So that's how we accomplish that.
Another question is, what if our devices do not have the capability to store or change certificates, say small sensors and low compute?
Great question. Dan, I'm happy to go first if you want me to on that.
Sure, go ahead.
Yeah, so as we both, Dan and I, touched on earlier, you've got different device classifications and capabilities as this whole IoT device ecosystem is evolving, and you've got these kind of what we would call brownfield, not particularly smart or capable devices that have been deployed for many years in machine-to-machine applications. And then you've got the new stuff that's coming out, stuff like, the Quark stuff from Intel, the Samsung Arctic platforms. The device capabilities that are coming have the ability, they have the storage capability, they've got the processing capability, they've got the crypto algorithm on board capability to support a much tighter security posture and introduce owner-controlled security posture. So for those environments that people have today that may not have those devices, what I would advise really is take a look at the security sensitivity of those applications, prioritize how you evolve your IoT device capabilities towards some of this newer technology that is going to allow you to introduce a tight security posture. So if those applications are sensitive, you're definitely going to want to make that investment to be able to evolve those environments. In the interim, I think we're going to have to rely on those IoT gateways that are out there from various vendors to basically facilitate the security, at least controlling it from the edge to the cloud and to the enterprise application.
Okay, very good, Talbot. Talbot, I appreciate that. We have a number of other questions coming in, so I just want to make sure we can get to some other questions from our audience, if that's okay. So we have another question here about how are OEMs accepting that IoT security needs to be baked in. Dan?
Yeah, that's definitely another good question. As we've visited in industry forums and with customers and whatnot, there seems to be a general acceptance that what we have today isn't good enough and that we need to build more capabilities with PKI into the stack. And with that being said, the customers that we've been working with have been quite receptive, especially in the design phase and consulting with DigiCert and partners on the best way to do this. Now, Talbot could talk more about the footprint that might be needed from from an architecture perspective, say with like ARM devices or something like that. But it is definitely a good point to draw out that with OEMs and the manufacturing process, that needs to be planned in up front, and it really does need to be baked in. It's hard to do this stuff after the fact, especially if you've got a lot of devices in the field.
Great. Talbot, do you have anything to add to that?
No, I think Dan's spot on with that.
Okay, very good. So we've received a number of other questions, and I want to just keep these rolling as much as we can. We have one about mutual TLS as a valid way to authenticate a device. First is that a valid method? And second, if so, what are best practices around protecting the private key on the device, especially, you know, if someone has a question about that. So Dan or Talbot.
Yeah, certainly. I think mutual TLS is definitely a good way to authenticate a device. And so this comes front and center around, okay, do you have mechanisms to request that key material, the secure channels built, and then just the whole life cycle of how are these devices going to present to, you know, the services that they're authenticating to. So definitely valid. I would definitely support it.
Yeah, and what I would say, and I would echo that, I think it is an important, you know, kind of element of that. I would say that where it kind of breaks down is in the protecting of the data when we look at how data flows from these devices to an IoT application. So the problem with that mutual TLS is the points between that the ends of that connection are what's performing that mutual TLS authentication, and behind that connection you can have things flowing into a cloud environment where the data is in clear text. So mutual TLS is a transport security that's protecting the flow of data between the device and whatever other and the connection that's speaking to. What's happening behind that is why we need to add in kind of very efficient data encryption on that payload so that it can flow end-to-end through a third-party network or cloud service securely back to an enterprise. So that end-to-end security is something that is going to be critical for IoT applications.
Okay, thank you, Talbot. We're going to address one other question here before moving on. We still have some others to get to, so keep bringing your questions. We'll try to get to as many as possible. One question, though, we did want to address right now is how about dealing with devices that may not be connected to the internet? So the attendee says that realizes that this technically is not an IoT device, but there are some systems which are not connected but still require certificate and key management.
Okay. Yeah, definitely a good question. It's something that has come up in many conversations with folks here at DigiCert and customers and whatnot. And the nice thing about the joint solution that we've highlighted is that the device authority capabilities can be on-premise as well as in the cloud, which would allow for scenarios like the offline mode that we're talking about here. Some industries are more sensitive to this, where they just don't want any connection to the internet, but still want the capabilities of key management, rotating keys, and strong authentication, etc. And I'm sure that you've got a thought on this one too, Talbot.
You know, I think that's exactly right. That's exactly right. Industrial health, there's healthcare applications, industrial applications that are not going to want those IoT devices communicating outside of that local network, and the key to this is being able to have an on-premise certificate provisioning capability and process that has controlled interface to a managed service like the Search Central service. So that can be brokered, it can be done on-prem in an isolated environment, and it's a very nice solution for those types of environments.
Okay. All right, so we'll go to the takeaways here then. So what we've seen is our recommendations to use and leverage PKI for identity with IoT devices. We're also emphasizing the fact that owners ought to establish an owner-controlled PKI for these IoT devices, and that's where the value prop really is. Also, we want to implement technology that automates the life cycle for IoT devices, such as seen in the joint solution here. And of course, we recommend consulting with partners who can assist in architecting the right solution that meets these needs. Anything else you have to add there?
Yeah, no, what I would say here is, you've got this kind of dichotomy here, right? You've got the concepts of PKI provide very strong security, principles that can be foundational to providing security for IoT applications. On the other hand, it's really, really hard to do, and a lot of companies are forced to do these things manually in order to get the benefits that they want out of their own PKI. The value of this solution comes in two forms. One is you've got the facilitation and the structure and the processes for validating the credentials with Search Central, and then you've got the help that you get with the automated orchestration that we provide with the Device Authority Keyscaler platform. So those two elements basically make it easier for organizations to get the benefits of PKI at the scale that they're going to need them for IoT, and I think it's kind of a great combination that makes owner-controlled security posture attainable and scalable and manageable for large enterprise deployments.
Very good. So appreciate the information so far, and we also appreciate all the questions that we continue to receive. It looks like this is a topic that people are very interested in. So we want to get to just a few more questions with the remaining time that we do have. One of the questions goes back to the demo, actually, Talbot. The question was that it looked like there was some manual configuration in the process of the setup in your demo. And the question is, once it's set up, is it automated? What's the automation in your system, in the joint solution?
That's a great question. So what you saw there really is we kind of reviewed the one-time setup elements to make that all possible. So the CN template, the provisioning policy, the group, those are all one-time setups. You get all that set up, as well as the DigiCert connector. So you set those up once, and you've got that rolling, and then it's just about adding devices to the group, and that is handled through that registration control that we saw, which can be bulk loaded, or it can be handled individually. But once we have those registration control records and they're getting consumed when the devices are coming in to connect, they get automatically added to the group. They get the policy of that group gets automatically applied to each device, and the credentials get automatically provisioned to the devices. So it makes it very nice and scalable.
Okay, very good. Another question that we've received relates to protecting the certificate on the device. What would you like to say about that?
I'll take a stab at that one. There's a lot of different capabilities in the devices today. Some have well, I'd say the differences in capability. So you've got everything from basically local drive storage or volatile storage that's on the device to TPMs and secure elements that have maybe trusted storage capabilities that can be provisioned and support the protection of keys and credentials inside of those trusted storage arrays. So it really depends on the makeup of the device, if you will, and with the capabilities that are there, obviously we can leverage what's there to support the process appropriately. So whether we're going to encrypt at rest that certificate and then have a authorized processing request the unwrapping and use of it, which would kind of be the low bar in that equation, all the way to it ends up getting provisioned straight into the TPM or secure element and then worked from there. And by the way, it's also true that you could start off with a private key generated from a secure element or TPM and then walk it back through this process to get it signed by the managed service for validation.
Okay, very good. Thank you, Talbot. Another question. I guess this one is more specific toward Dan. Someone asked about, we recently announced, actually just this week, an integration with DigiCert and our certificate management capabilities with Microsoft Azure. And someone is asking if this is an area that Device Authority plugs into.
Okay. Yeah, good question. So the answer is yes and no. We today allow anybody that wants to or that has an account with Microsoft Azure to create key vaults and store certificates in the key vault. Because that's available in the cloud, it doesn't, it's orthogonal to the joint solution that we've got with Device Authority. So it's feasible that those certificates that live in the Microsoft Azure Key Vault could be propagated through Device Authority / DigiCert mechanisms down to the devices. So it's not a tight coupling by any means, but it's certainly possible.
Okay, thank you, Dan. Someone joined perhaps a little bit late in the presentation. I know we covered a little bit about OEMs and some of the mistakes that are made commonly in the manufacturing process in terms of handling keys. And someone wanted to kind of go over that again. What are some of the common mistakes that we see?
So Talbot, I'll defer to you in the slide where you talk about that. I think it's good to hit it again.
Yeah, no problem. Well, I think the big mistake that's being made is that we're taking the concept of PKI private keys and we are propagating those keys so that they're no longer essentially private, and that means they become known, they become in essence public, or and that kind of undermines the entire security principles behind PKI. So that's the fundamental mistake. But there's also the reality that the device manufacturers are not really the ones that can be capable of solving this security posture issue for organizations. So they can introduce keys that can validate that those devices were manufactured by them, but going all the way to the point of taking ownership of that device and introducing it into your environment, I may know that it's one of those manufacturer devices, but somehow I have to get to the point that I know that it's one of my devices that I have deployed that my system is talking to. And that ownership transfer means that those manufacturers can't really solve that problem. There's some technology that's being introduced, by Intel that's designed to address that, problem. There are other ways to do that, as we've and this whole owner-controlled, registration is the key to being able to take that and introduce your own PKI into that environment.
Okay, thank you, Talbot, for that. Another question we received: if the certificate is stolen from the device, can you detect if it is used on another device?
And the answer to that, question. Oh, sorry, Dan.
You go ahead. All right.
Well, the short answer is absolutely we can. I mean, that's the point of coupling device authentication that is independent of those credentials with the credentials themselves. So if we have device authentication and we have certificate binding, then we can authenticate the device, or conversely, we can identify when an unauthorized device is trying to use another device's credentials.
Yeah, and I agree with what you said, Talbot. Plus, we didn't really get in the demo too much about the monitoring or auditing aspects of the joint solution. But that's another way to find out if there's a device that's behaving badly.
Yeah. So think about.
Okay, so we have.
Oh,
go ahead, Talbot.
Oh, I was just going to say, just to add to that, think about that when we talked about those authorization policies. Part of authorization is whether or not that device is coming in with the credentials that were assigned to it.
Okay, so another question. Someone was wondering about the Intel technology that you mentioned. I believe that was you, Talbot, in your discussion of various options that are available for folks. They wanted some clarification on what that was.
Yeah, so I think there was a recent announcement from Intel about the POC that they're working on, which is related to EPID and their Marshall Point technology. So that's what I was referring to there.
Okay, very good. Just a couple final questions as we look to wrap it up. One question, I think, Dan, this is from your slide where you were talking about the crypto that people are using for IoT security with PKI. Could you just touch on that a little bit more?
Yeah, we're just seeing in general, there's a trend to use elliptical curve cryptography. And it's something that we're seeing really across the board just because of lightweight aspects of it and still good security.
Okay, very good. I think that we have one or two, time for maybe one more question. So last question is, someone asked about familiarity with physical unclonable functions and if we have a method for integrating this emerging technology into the platform.
Okay, yeah, interesting question. I am actually familiar with a few vendors out there that do this sort of thing where they derive something unique from the physics of the device. So think the silicon is like a very unique characteristic, like a power signature or something like that. And that's not something that we've thought of today, but I think that it goes quite well with some of the other aspects that we've demoed in the joint solution. So when we think about ways that we can protect private keys, there's things, with the puffs, if you will, that could be leveraged for that.
Very good. So I think at this point, there may be a few other questions that you have that you'd like to ask. If we can go back, Talbot, we do have the information up here for everyone, so you can get information at DigiCert or Device Authority's website about the joint solution, about the approach to securing IoT devices, which we've talked about today. We also have contact information available here for email for Dan and Talbot, and feel free to reach out to them after the event, as I know that both Dan and Talbot will be interested in continuing the conversation after today's webinar. So I think this is a good point now to maybe ask Dan and Talbot if each of you has sort of kind of one closing statement or recommendation for folks before we close up today's webinar.
Sure, yeah, I'll just emphasize again that I think that PKI, we've demonstrated that it's a good fit, and we have an elegant solution that showcases the right balance of using it, automating the life cycle. So I just encourage you to learn more, check out the website, fire off more questions. If we didn't get to your questions, we apologize, but let's keep the dialogue going.
Great, and
Talbot, anything on your end?
Well, I would just say thanks to everyone who attended the webinar and stuck with it to the end. So thank you for doing that, and I hope that we provided some valuable information to you. And you know, I would echo what Dan said there. I think, you know, our goal here is to make PKI security, which is, you know, inherently a very valuable thing and is going to play a key role in IoT security. I think to make that as easy as possible for people to implement and manage, and that's really the goal of this joint solution. So thank you for your time today.
Very good. Thank you everyone for being here. I just want to remind you all that there will be an on-demand recording of today's webinar made available soon. We will email that out to you as soon as it is ready. Thank you very much for participating today, and have a great rest of your day.